Hey, so guys, why don't we gather up all the stuff that we need before we get started today? How's your day starting out? So, guys, you're actually going to want your homework packet, of course, because we're going to go over the homework in just a minute. And you're going to have a fair amount of time today to work on your homework for the next assignment as well. So grab your homework packets. Guys, 2 sheets of paper today. That'll make more sense in a minute. But please grab 2 blank sheets of paper. And then in addition to that, you're going to need a calculator and something to write with. So again, guys, homework packets, a couple sheets of paper, and calculators and something to write with. So, guys, I know that you are probably not in the habit of bringing calculators, but you are going to need them today. I'm willing to lend you one today with the understanding that you'll bring them in the future, so be ready to catch. Anyone else? Okay, we're going to try this. You ready? Nice. That was like coordination and stuff. So guys, again, and let's do this quickly so you have time to get to work today. 2 pieces of paper, 2 pieces of paper, calculators, something to write with, and your homework packets. So, guys, with that done, because by now you're either done or you're just not paying attention. Guys, typically on this homework assignment, the only questions that come up are relative to decimal places. Why is it that sulfur's 32.1 or whatever that may be? Guys, please remember that for today, what we're doing is we are rounding to 1 decimal place. That's going to change on Monday, but for now, that's how we're handling this. So with that said, guys, do you have any questions on any of these? Remembering, guys, that you didn't need to show this work, right? That all of, wait for it. There we go. Guys, all of this stuff is unnecessary. Please, if you can, don't show that work, because you're going to find out that this is a very small piece of a very big puzzle. And the less of that you can do, the better off you're going to be, because frankly, it's a waste of time. So guys, with that said, do you need any support on your homework? You guys really okay? Go ahead, McKay. Oh my heavens, yeah. That's actually why I gave you calculators, because you're going to see our phones don't deal very well with that, and we're starting even today dealing with more scientific notation. What I found though, and guys, let me say this to all of you. So long as McKay brought it up, let me mention this. So guys, there are multiple ways to put numbers in your calculator in scientific notation. And for years, Miss Call and I have actually started today by showing students the most efficient way to put numbers in their calculator in scientific notation. Then 2 nights ago, I sat down to help my daughter with her physics homework. She's a high schooler at Timpanogos. And she does it completely differently, learned it from her math teachers, and she's really good at it. So what we've decided, guys, is we are not going to muck with the way that you interact with your calculator. If you're getting the right answers, that's awesome. If you need help with scientific notation, I'd be happy to help, but actually just last night, yesterday afternoon, Miss Call and I decided not to talk about it simply because we don't want to do more harm than good. So, but if you need help, let me know. So, guys, really no question about homework? Okay, so here's what you're going to do. Put your homework packet away for now. You will be getting it out in a minute. Guys, what you're going to do then is grab one of the 2 sheets of paper that you got your hands on and do this. I'm going to put you to work. All right, so we need that. I can now I'll just do that later. All right, that goes away. This goes away. Grab a hold of this. All right. So guys, the date today is the 25th, and the topic for your notes today is dimensional analysis. So, guys, today, for you to be successful, and I'll let you write this down because it's important you hear this. You okay? So, guys, today for you to be successful is going to require an amazing amount of trust in me. Because, guys, what you're going to find is that the stuff that you are about to learn today, many of you, because you're bright and you're good with numbers, many of you are going to look at what I'm teaching you today and you're going to be like, I am not willing to do this because I don't need to. This is silly. The questions are stupid. I don't care about the answers. I'm just going to muscle through these and get the points on the homework by getting the answers correct. Guys, please don't make that mistake. What we're doing today is we were learning a process called dimensional analysis. Now, guys, the problem is that we don't yet know enough chemistry to actually need this. So, guys, what you're going to see today, and I'm just going to be really upfront with you, what you're going to see today is we are going to be solving a bunch of really stupid problems. Because the problems and the answers are not the point. The point is the process. So guys, please just trust me for today. And please invest in understanding this process. Because guys, if you don't understand this process, when I see you on Monday, you're going to be like, oh crap, he wasn't kidding. Because on Monday, we're going to bring chemistry into this, and you aren't going to be able to solve these without the process. So guys, please learn the process in this assignment so that you can use it for the rest of the year, because it's absolutely critical. So guys, with that said, how stupid are these questions? Ready? That's how stupid they are. How old are you in seconds? Guys, we don't care how old you are in seconds. But with that said, in the next 3 minutes, on your notes page, figure out how old you are in seconds. Do it. How old are you in seconds? Do it on your own. Do it on your own. Guys, don't talk about it. Figure it out. How old are you in seconds? Grabbing your calculators, plugging in numbers. How old are you in seconds? If you need a place to scratch down ideas, use your notes paper as the place to do that. Some of you are writing, some of you are typing on your calculator. But guys, as you're doing this work, let me explain. Let me make sure you're clear. Guys, we really don't care how old you are in seconds, right? It doesn't matter. Well, it's kind of cool to think about, but guys, the bottom line here is we're learning a process. And to do that, these are the kind of questions that we're going to answer. Okay, you done? Oh, that's up to you. But Jessica, questions like that are the things we're going to talk about. Does your answer need to be in scientific notation? We'll talk. Totally up to you. Say what? Now we're starting to think about this, right? So how accurate do we need to be, right? And interestingly, how do we communicate accuracy? Significant digits. Guess where this is headed? So guys, you got another 30 seconds. Hopefully by then McKay will be done wandering around and we'll be ready to go. You okay? Oh my gosh, we're going to talk about that. Yeah, and by the time McKay sits down, sorry, I keep picking on you, all of our answers are going to be wrong because it's going to be 30 seconds later, right? We'll talk. So, say that again? I didn't go that specific. Well, and so how specific should we go? So guys, do this, please. Regardless of the answer that you came up with, please explain to the person next to you how you arrived at your answer. Talk about it. McKay, did you get an answer? And you know I'm just giving you crap. I'm going to quote you on that.
I just said I went down to 16 at 230.
There you go. Hey, so guys, you got about 10 more seconds to wrap up your conversations. Hey, so allow me to pull us together and allow me to make some observations, if you would, please, simply because I was eavesdropping on your conversations. So, guys, as we were talking about this, there were all sorts of interesting ideas, but also glaring weaknesses that came out in your conversations. I heard Jessica talking about this idea that I'm 16, but almost 17, but I wasn't that specific. Then we're talking about, do we put numbers in scientific notation? How do we handle this idea that we're not, that how specific do we need to get? And then I heard some of you talking about how many days are in a year, are in a week, are in a month, are in an hour, are in a minute. And you're breaking down these things in your head and they get muddled and they get jumbled. And I heard some of you talking about multiplying and I heard some of you talk about dividing. And guys, the bottom line is a seemingly easy, and we all agree, stupid question, guys, brings up so many examples of how we need a system to solve systematic problems. And guys, that's what you're going to learn today. Again, we don't care about the answer, although it will be interesting to talk. You're going to find this interesting. But guys, again, ultimately, we really don't care about the answer. What we care about is the process. And so, guys, what I'd like to do is I'd like to introduce you to the process. And so I'm just going to lay this out. We are going to solve this in a minute. But guys, before we do, I'd like to lay out for you the process. And guys, I would strongly encourage you to scratch this in your notes because literally these are going to be our marching orders as we solve these problems. In order to do this effectively and systematically, we need steps. And guys, I really would encourage you to write these down because we're going to come back to these. And when you struggle, if you struggle with these, when you come in to get help, and guys, please, if you don't come in to get help after school, the only thing I have to do is watch bike racing. So please, we come and we'll watch bike racing together, and then we'll talk about chemistry. So guys, please come and get help. But guys, the steps go like this. Step number 1 is determine your goal. Our good friend Franklin Covey, Provo's golden child, start with the end in mind. Do they still teach that in elementary school? Oh boy, no? All right. So guys, anytime you're solving these problems, you always start with a goal. Then step number 2 is to figure out your starting point. By the way, guys, only write down the things that are underlined. Sorry, my bad. Then step number 3, and frankly, this is the part that I struggle with the most because I'm a left-handed guy. Draw a straight line from left to right. Mine tend to look more like slopes, which is why you'll see I actually typed up my calculations just so they look better. So guys, we've got a goal, we've got a starting point, we've got a line. Then step 4 is conversions. Now guys, when we apply these conversions, they have to meet 2 criteria. And this is going to mean absolutely nothing to you, but you've already talked about them, right? Weeks and days and hours and minutes and months and seconds and oh my gosh. Those were your conversions. But guys, there's two things that have to be true of them. Number one, they've got to be fractions that are equal to 1. We'll talk more about that in a minute. And then additionally, guys, number two, they must cancel. Now, Jessica, again, I was sort of eavesdropping on you, and I heard you talk about canceling. Have you done dimensional analysis before? Here? You guys learned? I thought she wasn't teaching this anymore. Yeah.
Like 365 days over 1 year.
Yes. I thought she wasn't. So, well, let's talk about that. So, if you've taken physics, you already know dimensional analysis? Did you love it or hate it? Kind of in the middle? Well, guys, if you already know this is going to be a glorious refresher, but I thought she wasn't teaching it anymore. Interesting. All right. But I will promise you this. Even if you've already learned it, you're still going to learn something today. And if that's not true, I'll buy you lunch. Seriously, take me up on it. I guarantee you're all going to learn something today. So let's keep going. Guys, number 5. Solve for your goal. And in order to do that, you multiply by the top and divide by the bottom. And then, guys, finally, number 6, you round to the least significant digits. So again, the steps go like this. Goal, starting point, line. And guys, there should actually be a step 3A. Goal, starting point, line, sigh of relief. Because guys, once you've got those first 3 steps done, these become very, very mechanical. The hard part's figuring out your starting point and your goal. Once you've done that, the steps can just sort of fall into place. Step number 4 is apply conversions. Step number 5 is to do the math by multiplying by the top and dividing by the bottom. And then, guys, step number 6 is to round your answer. So, guys, once you've got these all down, here's what we're going to do for the rest of the day. We're going to solve our minutes to our years to seconds question. Then we're going to do 2 more. And then, guys, after that, you've got time to work on your homework. That's what that other sheet of paper is for. Because if you've done these before, you know that you can't cram them onto a small sheet of paper you need space to work. So that's what that other sheet's for. You guys good to go? We okay? Can I move on? You got it all down? Here we go. So guys, what we're going to do now, and again, we care about process. We don't care really about the answers. Guys, we're going to take these 6 steps. Goal, starting point, line, conversion, solve, and sig figs. We're going to take these 6 steps and we are going to apply them to this question. Now guys, in order to do this, I know that we have a range of ages in the room. I'm going to use 17 as the average because that's typically what it is. So guys, I'm going to do the calculation based on a 17-year-old. If you're 15 or 18 or 16 or whatever, you can use your own numbers or you can pretend you're 17 for a couple minutes. But guys, let's start. What is our goal? So how old are you in seconds? What's our goal? How old are you in seconds? So guys, you want to go, please do this. You want to go all the way to the right-hand side of your page and you want to write down the abbreviation for seconds. Go all the way to the right. And guys, understand this is not just the process for solving this problem. This is the process to solve all of these problems. So now we need a starting point. So guys, this is the way to figure out your starting point. Ask yourself this question. I want to know how old I am in seconds. What about me will determine how old I am in seconds? Your age in years. So we're going to go all the way to the left, and that's going to be our starting point. And again, I'm going to use 17 as my age in years. Now, guys, let's get started. Step number 3 is to draw a line like so. From looking, Isaac, can you show me the thing that you... Here, let me come to you. Is that... Yeah, no, that's fine. Did you learn that from Leosa? Okay, so guys, if you learned this in physics and you learned it as a fraction times a fraction times a fraction times a fraction, that's fine. Understand what I do is I just draw one big line and then all the fractions sit on that line. I would ask that you at least try it this way. I think you'll find that given the way we do this in chemistry, it may make a little better organizational sense. Okay, so here's where we are. 17 years, we're going to seconds, we drew our line, now we need to make some conversions. So guys, this is the way to approach making conversions. Ask yourself this question. So try to solve the problem in one step. How many seconds are in a year? I turn it to you. How many seconds are in a year? We don't know, right? So if we don't know the answer to that, then we ask this question. What can I break years down into to get closer to seconds? Days. Okay, now guys, watch. It's going to come up in red. Don't write it down, but this is the idea. Do we all understand that there's 365 days in a year? Is that okay? So think about this. Literally, that equal sign means these are equal, right? 365 days is equal to 1 year. So if that's true, let's turn that into a fraction. So 365 days over 1 year, or 1 year over 365 days. Here's a question. Guys, mathematically, what are both of those fractions equal to? 1. Let that soak in. These are equal to 1, because this is equal to that, and any number divided by itself is 1. Does that make sense? So this is equal to 1, and this is equal to 1. So now all we got to do is figure out which one do we use, the one on the left or the one on the right, and here's the answer. Whatever's on top here has got to be on the bottom here, so so they cancel, conversions and cancel. So guys, this has got to be down here, so this is the form of the fraction that we're going to use. So all you got to do, guys, is whatever's on top here goes on bottom there. So 1 year, 365 days. Now, guys, what do we do with this? Well, the next thing we do is we cancel units. So years cancels with years, and if we stopped right there, we'd be in days. But are we done? Why not? Because we need seconds. And guys, please get used to asking yourself that question, because when this turns into chemistry next week, many times you're not going to know when you're done unless you ask that question. So you go, days are not seconds, so I'm not done, so I need a line, and I need to do another calculation. So guys, how many seconds are in a day? We don't know. So what can we take days into to get closer to seconds? Hours. Now guys, 24 hours is a day, right? Which goes on the bottom, the days or the hours? Boom. Whatever's on top goes on bottom, so 1 day, 24 hours goes on top. Now we cancel. Days cancels with days. We're left in hours, but we're not done because we ain't in seconds. So then, guys, we just rinse and repeat. The next question is, how many seconds are in an hour? We don't know. So what can we take hours to get closer to seconds? Minutes. 60 seconds in a minute. Wait, minutes? Hours to minutes. 60 minutes in an hour. Guys, what goes on the bottom? The 1 hour or the 60 minutes? 1 hour. 1 hour on the bottom, 60 minutes on top. The hours cancel, and now we're in minutes, but we're still not done. But now we know the answer to the question. How many seconds are in a minute? How many seconds are in a minute? 60. And now, guys, which one goes on the bottom? The 1 minute or the 60 seconds? Good. So 1 minute goes on the bottom, 60 seconds goes on the top. The minutes cancel out. And now, guys, we are done. Here's why we're done. Because the only unit that isn't canceled is the same as our goal. That's how you know you're done. So now, guys, we need to do the math. So remember, when we do the solving steps, we multiply by the top and divide by the bottom. So guys, grab your calculators. Oh man, my calculator went home with me last night. So guys, grab your calculators and let's do the math. So here's what we're going to do. We're going to take 17 and we're going to multiply by the top. So we're going to multiply by 365. Then we're going to divide by 1, which doesn't change the value of the number. Then we're going to multiply by, oh, holy smokes, I'm struggling. And then we're going to multiply by 24. And then divide by 1. Don't do it. Doesn't change the number. Then we're going to multiply by 60. Divide by 1. Don't do it. Multiply by 60. And then divide by 1, which doesn't change the number. And guys, I get 536112000. Can you confirm? Okay. So, and hopefully that's what comes up here. I did this late last night. Come on, baby. 5361120. Huh? Yeah. Look at me go. Did you all get that answer? You good? Because it's wrong. Guys, this is not the answer to this question. And many of you in your conversations understand why. If you don't understand why, hold your breath for a second. Now it's wrong by a second. Let McKay walk around again for 30 seconds, and now it's wrong by 30 seconds. But guys, it's even wrong for another reason. Are any of you 17 years old? Any of you? 17? Liar. Guys, do you understand that? If somebody asks you how old you are and you say 17, the only thing you're really saying is you're not yet 18, right? So London said she's 17. It could be her birthday today. Happy birthday, you're 17. Or it could be her birthday tomorrow, and she's 1 day short of 18. So guys, understand, when you tell somebody your age, you're actually representing 364 days of range in terms of how old you actually are. So guys, the deal is this. This number, check this out, this number is not very accurate. And because this number is not very accurate, this number cannot be very accurate. So guys, now we need to do step 6, and we need to round to significant digits. So guys, do this with me. We're going to go to each one of these things, and we're going to figure out how many significant digits are in the number. So guys, how many significant digits are in 17? 2. Write it down up above the number. Now guys, watch this. How many significant digits are in 365? 3. But now watch. What about the 1? It doesn't matter, guys. Here's what you're going to see. All of your conversions will have one factor that is a 1. That is a point of reference, and you don't need to worry about it. So all you do is look at the other number, and 365 is 3 digits of accuracy. Now guys, check this one out. This one's tricky. This could probably save me lunch. You ready? How many significant digits are in 24? Now you're hesitating to answer, right? Because how many digits are in 24? 2? But it's not 2. Guys, the answer is actually infinity. Write it down and then let's talk about it. So guys, do this. How many days are in and out? How many hours are in a day? 24. But is it ever 23.9 and we just round to 24? Or is that 24.1? Guys, it's exactly 24. That is not a measurement. That is a definition. 1 day, by definition, is 24 hours. But guys, what about this? Is 365 days really a year? No, it's actually 365.24. Did you guys know that? That's why we have leap years. Instead of moving our calendar ahead a quarter of a day every year, we gather those days together, and every 4 years we add an extra day to our calendar because a year is actually 365.24 days. But guys, what do we do with the fact that it's 0.24 and not 0.25? Do you guys know this? We skip a leap year every 100 years. Do you guys not learn anything in school? Okay, that's fair. So guys, really that's what but bottom line is this. Are you all comfortable with the idea that this is not perfect because it's not exactly 365? Is 17 years perfect? No, we don't know how old you are really. So this isn't perfect, but that is perfect. And because it's perfect, it doesn't limit significant digits. Is that cool? Okay, so talk to me about 60 minutes in an hour. Is it really 60 minutes in an hour? Every single time. Guys, that is perfect. What about 60 seconds in a minute? Is that a measurement or is that perfect? That's perfect. So that is also infinity. So now, guys, what we need to do is we need to find the smallest number. So we've got 2, we've got 3, and we've got a bunch of infinities. So 2 is the smallest. So, guys, we are now going to round that number to 2 significant digits. So to do that, there's 1, there's 2. The 6 tells us to round up. And I get, oh heavens, I get a screen that's not cooperating. And, guys, I get 5, 4. This needs commas. So what is that? Bump. 540 million? Is that right? Guys, that then is our answer. To the accuracy that we can represent, we know that a 17-year-old, like London, is 540 million seconds old. So guys, look at everything we did. Even if you knew how to do dimensional analysis, I doubt that you got involved in this idea of accuracy and significant digits and representing errors fairly. So guys, this is the way that we're going to solve these problems for the rest of the year. Yeah. It's always the smallest. Thanks for bringing us back to that. And here's why. Your answer can't be better than your data. So if your data is only accurate to 2 digits, your answer can only be accurate to 2 digits. Great point. Yeah, McKay? That's a great question. And again, today we're doing stupid stuff, right? Like seconds in a year. What you're going to find is that when we really get into this, you'll know. And actually, the next question that we're going to solve, we'll talk about it in just a moment. But that's how do you know when they're perfect? And we'll talk. You guys good? Can we answer another stupid question? Is it bad that I call them stupid? So what about this? If Larry weighs 125 pounds, what's his mass in grams? We don't even know who Larry is. He's not very big. But guys, we're going to solve this problem. Here's what I'd like you to do. And again, this is what I'm asking you to trust me on. You look at this and you're like, seriously? But guys, again, we're learning the process. So please get over seriously and learn the process. So guys, here's what I'd like you to do, kicking you out of the nest a little bit. Do the first 3 steps without me. Do the first 3 steps without me. Again, if you're not sure what we're referring to by first 3 steps, I've written them down for you as a reminder. And guys, please, I know that we are accustomed to working left to right. Please don't. Please always set your goal first. Start on the right, then go left. So guys, let me catch up with you. It says Larry weighs 125 pounds. What's his mass in grams? What are we solving for? Grams. So we're going to write that all the way to the right, right? Then, guys, after that, we need a starting point. And, guys, please don't miss this because this will get harder later. If you're not sure how to determine your starting point, ask this question. What about Larry determines his mass in grams? What about Larry determines his mass in grams? His weight in pounds. That's where you start. Then, guys, you draw a line from left to right. And then you ask this important question. How many grams are in a pound? And what's all of our answer? We don't know. Or you Google it. Well, guys, we're not going to Google it. I have a reference for you. Oh, I know. This also is fair game for the rest of the year. So now you have periodic tables, ion charts, and conversion tables. And McKay, we're about to answer your question. Good heavens, I can't get these apart. There we go.
Okay, so even though
Okay, guys, look these over with me if you would. McKay, you okay? McKay. All right. So, guys, please look these over, and we're going to talk about McKay's question. So, guys, notice that these are broken into English, metric, and English to metric conversions. Then you'll notice from left to right it goes length, volume, and weight. So, guys, looking at this, let's look at our English conversions first. You ready? 12 inches is a foot. Is that really true? Is 12 inches really a foot? Okay. What about the middle? 2 cups is a pint. Really? Yeah. Guys, what about 16 ounces is a pound? Is that really true, or is that just close? That's really true. Guys, all of your English conversions are perfect. You may want to write that down next to where it says English system. These are all perfect. Consequently, do they limit significant digits? No, they are infinitely accurate. Now, guys, do this in the middle. 10 centimeters is a decimeter. Really? Yeah, really. In the middle, 1,000 centimeters cubed is a decimeter cubed. Is that always true? Yeah, it's always true. Then on the right, guys, 1,000 milligrams is a gram. Oh, yeah, that's always the case. Guys, these metric conversions are perfect. You may want to write perfect next to the metric conversions. Then, guys, down at the bottom, English to metric. 1 inch is 2.54 centimeters. Really? Yeah, really. That's actually perfect. But then, guys, go down below that. 1 meter is 39.37 inches. Really? No, it's close. Go to the middle. A liter is 1.06 quarts. No, it's not. It's in the ballpark, but it's not. And then, guys, off to the right. A kilogram is 2.2 pounds. Yeah, sorta. So, guys, these English to metric conversions are not perfect. Therefore, they do limit significant digits, except for 1 inch is 2.54 centimeters. And ladies, I fear that you missed all of that because you're concerned about your lotion. You can get it from someone else later. So, guys, again, the English and the metric conversions are perfect. The English to metric are not, with the exception of that one that we talked about. Yeah, Rat?
So would we assume because even though it gives us Larry's weight of 25, are we going to assume that it's not exact?
Absolutely it's not. Yeah, I mean, you get on your scale. I mean, think about it. Like, my bathroom scale is digital, and it pretends to measure down to tenths. But if you're on a bathroom scale with a dial, right? So, yeah, no, and that's actually an interesting point, Rat, that all measurements are not perfect. What that means is your starting point will never be perfect because we're always converting measurements. So your starting point will never be perfect. Okay, so guys, let's start again. Ready? Asking ourselves the question one more time. How many grams are in a pound? We don't know. So guys, what can we take pounds to in order to get closer to grams? Guys, look at your sheet. What can we convert grams? What can we convert pounds to get closer to grams? So we could go pounds to ounces. Guys, what else could we do? Pounds to kilograms. Now, guys, which one's right? And the answer is they're both correct. And if you do either one, you will get exactly the same answer, 2 significant digits. So I chose to go pounds to kilograms. So guys, watch my hands. 1 kilogram is 2.2 pounds. Which one goes on the bottom, the kilograms or the pounds? Pounds on the bottom. So 2.2 pounds is 1 kilogram. If you would like to go pounds to ounces, go for it. We'll get exactly the same answers. So guys, now our pounds cancel, and we are left with kilograms. Are we done? No, because kilograms are not grams. So now we need another conversion. How many grams are in a kilogram? Do you see it? 1,000. Which one goes on the bottom, the kilogram or the 1,000 grams? kilogram. So kilograms are on the bottom, grams are on the top. Kilograms cancel. We're left with grams, which is our goal, so we know we're done. So now guys, we've got to do the math. And we go 125 divided by 2.2 times 1,000, and I get 56,818. So 56,818. But again, guys, that's not the answer because we need to round to significant digits. So why don't you try it, and then we'll talk. Figure out how many significant digits are in each one of these numbers and conversion factors, and then round. So guys, let's take a swing at this. Rhett brought up a really, really good point that this first number can never be perfect because it's always a measurement. So guys, how many significant digits in 125? There's 3. Now let's talk. We know that we don't ever look at the 1 because that's a point of reference. Is it exactly 2.2 pounds in a kilogram? No. That's an English to metric conversion, which isn't perfect, so that would be 2. Do we need to talk about that more? Then guys, what about 1,000 grams as a kilogram? Perfect? That one's perfect. It is a metric to metric conversion. That can't get any better. So that is infinite significant digits. So we've got 3 and we've got 2 and we've got perfect, which gives us 2. And therefore that bottom number rounds to 57,000. You good? Yeah.
I went from pounds to ounces.
Yeah.
Does it make this significant digit?
It does, because if you go pounds to ounces, that's perfect, 16 ounces. And then your next conversion is ounces to grams, 28 point something. And that's 3 significant digits. And so yes, in that case, you would get an additional significant digit. But it should be close to the same. Go ahead, Rhett.
Yeah, so, yeah, the answer I got from going to ounces to grams, and I is,
Right, which is the same. If you were to round that to 2 significant digits, we'd end up in the same place. You get an additional significant digit because you have your limiting conversion is 28.4 grams as an ounce. So you'd get an additional significant digit, but our answers are technically the same. Go ahead.
would both answers be correct on test?
Yeah, which makes grading this test like 0 fun. Because what you're going to find is these get more complicated. Some of these problems have 3 and 4 different ways to solve them. And I have to make a key that includes all of those. So yes, either one of those is valid. Yep. What else, y'all? Okay, so I typically at this point, you're settling into this. You're like, okay, I understand the process. We need to solve one more problem. Guys, there's another way to approach this problem-solving structure that you need to know. So we've got one more problem to solve, and then I'm going to get out of your hair and let you work on homework. But guys, it's especially critical that you solve this problem exactly like I do, because if you don't, you're going to find that you're really going to get stuck in a couple days. So with that said, silly examples, right? And you guys are going to come and get help tonight if you need it and keep me from watching bike racing? Well, guys, right now, the professional cycling season is actually finally kicked off, even in the days of COVID. And they're right now racing what's called the Uea Tour. It's being raced in the United Arab Emirates. It's in the middle of the desert. And guys, it started on Sunday. And this year's opening stage was crazy because the ride was pan flat. There was no elevation gain in this race. And guys, people were dropping out of the race because they were so exhausted. So what was it that was kicking their butts? It wasn't the hills, it was the wind. Guys, this is actually a screen capture from the video of the race. And what these guys do is they ride in what are called echelons. And you can actually see, if you look in the distance, the sandstorms blowing across the road. And what ends up happening is the riders that the teams are protecting in order to get them to win the race, they actually shelter them from the wind. But the problem is the wind is blowing across the road. So what they do is they build these echelons where these guys over here are the riders that are eventually probably going to win the race, and all these guys are the workers that are trying to protect them from the wind. And guys, eventually these echelons got separated by minutes. And if you don't understand the significance of that, the Tour de France, which is a 21-day race, these guys race about 2,200 miles in 3 weeks. And last year, the winner won by 62 seconds. A 3-week race, and the margin of victory was 62 seconds. And this race blew up by minutes at the very beginning. It was ridiculous. Anyway, so all of that to say, even in these scorching winds, guys, in the beginning of this race, for the first half of the race, these guys averaged 17.2 meters per second. And you're going, yeah? Well, what I'd like to do is I'd like to figure out how fast that is in miles per hour. So we're going to do that. But guys, in order to do this, please allow me to guide the process. I'm not going to let you do this on your own. So guys, let's talk. Don't write down the problem. Let's just talk. What are we solving for? What's our goal? Miles per hour. But guys, please hear this. What does the word per mean mathematically? Divided by. It's miles over hours. Guys, if you do not write your goal exactly like this, you're sunk. This is the important additional skill that you're learning right now. It's miles over hours. If you don't set it up like that, you're done. And here's why. Guys, how fast do we know these guys are going? 17.2 meters per second. And guys, this is the trick. When you set that up, it's 17.2 meters over 1 second. Guys, these are what are called complex conversions. What's going on now is we have a numerator and a denominator, and we have to convert both. So guys, if you're not sure what I'm talking about, once you've got this all written down, let me show you. So guys, we are starting in meters, and we need to convert that to miles. And we're starting in seconds, and we've got to convert that to hours. And it's critical that you learn to do this on the same line. Coming at the tail end of next week, guys, this is going to be a very important skill for you. So, guys, it doesn't matter which one you do first. You can do the numerator or the denominator first. I like to do the numerator first because I just start on top. So let's do this. Guys, we asked the question, how many meters are in a mile? Grab your white sheet. How many meters are in a mile? Well, guys, we don't know. So what can we take meters to in order to get closer to miles? Meters to kilometers. Guys, let's do this. How many meters are in a kilometer? How many meters are in a kilometer? 1,000. Which one goes on the bottom? The 1,000 meters or the 1 kilometer? 1,000 meters is 1 kilometer. Now, guys, we cancel. Meters cancel out with meters. We're left with kilometers. Are we done? No, because we want to be in miles. So now we look it up again. How many kilometers are in a mile? 1.6. What goes on? And I just know that because I'm always doing this math when I watch European cycling because everything's in kilometers. So guys, 1.6. So what goes on the bottom? The 1.6 kilometers or the 1 mile? 1.6 kilometers, 1 mile. Now kilometers cancel, and we are left with miles, so we are done with the numerator. But guys, if we stopped right there, we would be in miles per second. And that's meaningless to us. We want miles per hour. So now, guys, we've got to deal with the denominator. How many seconds are in an hour? We don't know. So what can we take seconds to get closer to hours? Minutes. Now, guys, watch. This is different. How many seconds are in a minute? 60 seconds in a minute, right? But now, guys, we're canceling from the bottom to the top. So it's 60 seconds in 1 minute. And now we're flipping our conversions so that they cancel bottom to top. Are we done? We are not done, because now we need to get minutes to hours. We know that 60 minutes is an hour. Now, guys, which one goes on top? The 60 minutes or the 1 hour? 60 minutes goes on top, the 1 hour goes on the bottom, and now minutes cancel with minutes. And guys, now we have hours in the denominator, and now we're done. So now, guys, we do the math. So we go 17.2 divided by 1,000 divided by 1.6 times 60 times 60. And guys, notice that I'm multiplying by what's on the top, I'm dividing by what's on the bottom, and I'm skipping the ones. And so being done with all that math, I get 38.700 miles per hour. Holy smokes. Guys, they were almost going 40 miles an hour into a 40 mile an hour headwind. It was nuts. Well, they call it a cross headwind. It's actually coming like this. Yeah, it was brutal. But guys, we're not done. We need to round to significant digits. So let's do this. So 17.2, that's our starting point. That is never perfect. That's 3. Now, guys, what about 1,000 meters is a kilometer? That's perfect. What about 1.6 kilometers is a mile? That is not perfect because it's an English to metric conversion. That's 2. And then our time conversions are both perfect because those are definitions. So that leaves us with the fewest. As London pointed out, we always want the fewest. That's 2. So guys, that's 39 miles an hour. That is a ridiculously hard day out in the wind. It was a mess. So guys, questions or things you want clarification on? Do I owe any of you lunch? Not just because you want to have lunch with me. That would be really sad. Y'all learned something. So guys, with that said, we are now doing homework assignment number 2. And as I said, gang, we don't care about the answers. Guys, we are concerned about the process. So here's what we're going to do. We are going to do the odd numbered problems for accountability. So guys, when we get together on Monday, do we have school Monday? We do, right?
Yeah.
Is next week a normal? Okay. So when I see you on Monday, guys, we are going to hold ourselves accountable for only the odds. If you want to do all of them, that's awesome. We can answer questions about all of them, but only the odds for accountability. But guys, here's the deal. Do them on another sheet of paper. Again, guys, we don't care about answers. We care about process. Because when I see you on Monday, guys, the understanding is you know how to do these. So if you need support, please come and grab me before school, after school. I'd love to get together. And guys, we're going to spend the rest of the day today plowing through these. Please remember the replacement test is next Tuesday for the test that we just took. Oh, and by the way, this, guys, when you look at Skyward, don't panic. I have added categories in Skyward for all of the assignments that we still have on third quarter's grade, just so that you know what's coming. We have 3 more homework assignments and 1 more project, activity, lab-like thing. And that's it. So guys, the rest of the time is yours. Please ask if you need. The answers are on the wall.